Assalamu alaikum, dear students. This is Professor Shafqatul Mulk. From today, I am going to start a series of lecture in the field of digital logic design. In this series, today I am going to give you lecture number first. In this lecture number first of all, I am going to tell you about the DLD. DLD is abbreviated name for the digital logic design. The first point in the digital logic design is that this DLD is the first course in the digital systems understanding. Suppose if you have to understand about a bigger digital system, so you cannot directly start that course. Before starting that bigger course, you have to understand the DLD first, because DLD gives you insight of the basic foundation of the bigger systems. So as this is a very first course in this series, so there is no prerequisite for this course, and this is a good point. It means the beginners or the novel type of people can start this course. In different universities, this course is taught in two credits. By two credits mean that two lectures each of 1 hour will be taken, and this way this course can be finished in one semester. As I told you that digital systems is taught from the basics of the digital logic design. So we can say that DLD provides the solid foundation for the bigger digital systems. There are different types of bigger digital systems, but academically we can say that microprocessor and microcontrollers. These are the bigger digital systems. So in order to understand the microprocessor and microcontroller, we have to know the foundation course, and that is digital logic design. You know that microprocessor is the vital element of the computers, as well as it is a vital element of the mobile. And for different types of the digital systems, we have this microcontroller as the main brain of that system. Suppose if you talk about the ATM machine, or if you talk about the vending machine, or let's say we talk about the automatic washing machine, and much more, let's say we talk about the digital LEDs. So every digital system have microcontroller, some type of the microcontroller inside it. So in order to understand the basic working principle of those bigger systems, we have to understand first the digital logic design, and then we can move on toward the microprocessor and microcontrollers. Now let me explain the three words of this course. So first of all, we can see a word logic in the digital logic design course. What is meant by a logic? A logic is intelligence. Mean the verbal meaning of logic is intelligence. So the elements used in the digital systems are the intelligent elements. And those intelligent elements make up the bigger systems. Second word in the digital logic design is the digital. So why we are talking about this word digital? By digital means that the logic elements in the digital system will get zeros and ones as the input data, and it may produce 0 or 1 as the output data. So all the digital elements operates on the zeros and ones, so it is why it is called digital logic. The third word in the course is the design. You know that design mean if you do not have any type of the system, and if you want to design it from the scratch, so you have to apply some design practices. So in this course we will also be able to learn about some design practices. What are the DLD learning components? Because this is an introductory class, it is why I'm going to tell you about the basic element what are used in the bigger digital systems. So the basic logic gates, or in other words, we can say that the building blocks of the digital systems are these three gates: AND gate, OR gate, and NOT gate. AND gate is a basic element which makes certain decision. OR gate is also a basic logic element which makes certain decision, and same is the case for the NOT gate. So these are the three fundamental elements for the bigger digital systems. Digital logic design or the logic circuit can be divided into two main parts: the combinational logic circuits and the sequential logic circuits. So this course is also limited to these two basic concepts: the combinational logic circuits and the sequential logic circuits. Combinational logic circuits are those circuits which do not have memory elements. It means the logic elements used in the combinational logic circuits cannot retain the logic, cannot memorize the concept. Whereas in sequential circuit, we have the memory elements and it can retain the logic, it can store the logic. In order to understand the combinational logic, we will go through some design procedures. And in those design procedures, we will use the Boolean algebra design approach, the K-maps design approach. And the third one design approach is the using of the Verilog HDL. So Boolean logic and the K-map logic and Verilog HDL logic will be used to design the combinational circuit. After utilizing these design practices, we may design some standard combinational logic circuits. The very well-known standard combinational circuits are the encoders, decoders, multiplexer, and the short name of the multiplexer is mux, adders, subtractor, etc. And in the sequential circuit, we will use another design tools in order to design the sequential logic circuit. And that design tool is called state machine approach. Through the application of the state machine approach, we may design some standard sequential logic circuits. The examples of the standard sequential logic circuits are the latches, the flip-flops, the registers, and counters. And in addition to these, there is one more very important sequential logic circuit, that is memory. And then programmable logic devices like PAL, which is the programmable array logic, and PLA, which is the programmable logic array. These are the two types of the PLDs, programmable logic devices. It will be discussed in detail in this course. As I told you that in today's world, the digital circuits are having millions number of gates. So sometimes the conventional design approach like the Boolean algebra, the K-map, and the state machine approach cannot work. In that type of situation, we use the HDL approach, hardware description language. By hardware description language mean we apply the software practices in order to design the hardware logic circuit. So Verilog HDL and VHDL is used in that context. And the programming language is used to design, or it may be used to simulate the digital hardware. So in this course, in short, we will talk about the combinational logic circuit and its design approaches, sequential logic circuits and its design approaches, as well as we'll talk about the Verilog HDL. So that's all about this course. So hope that you understand. So if you have any question, so please ask me in the comment section. I will love to answer those questions. Or if you want a video on any other topic which relates to digital logic circuit, you may ask me in the comment. I will try my level best to prepare our short video in that area as well. Thank you very much. God bless you. Allah Hafiz.